So now we move to find the sine and cosine of a multiple of 30 degrees. And let's first look at this unit circle. And we begin with the angle of the 60 degrees. So we can draw a perpendicular from this point of intersection to the x-axis. In such a way, we can form a right triangle. You see, this is 90 degrees, and this is 60 degrees, and this is the 30 degrees, right? And we can take this triangle out, and then we make a copy of it, and we put this copy just beside it, and then we can form an equilateral triangle. So that means the length of this neck of this right triangle is equal to the half of the length of the hypotenuse, which is equal to 1, because this is a unit circle, right? So this is the radius of this unit circle, that is equal to 1. At the same time, this is the hypotenuse of this right triangle. So now the length of this neck is half of the side of this equilateral triangle, and we know this equilateral triangle has the length 1 because this hypotenuse is 1. So we know the length of this neck is equal to 1/2. So that means this x-coordinate of the point of intersection of this terminal side of the 60 degrees is equal to 1/2. So now this guy here, this is equal to 1/2. So that is x is equal to 1/2. Okay. And at the same time, we know x and y satisfy the equation of this unit circle. So when we have the x squared plus y squared equals 1, then we plug in 1/2 into this equation, we get square of 1/2 plus y squared equal to 1. And then we get y squared equal to 1 minus 1 over 4. So that is y squared equal to 3 over 4. Then we take the square root of both sides. Then we get y equals plus minus root of 3 over 2, right? Root of 4 is equal to 2. So that means the point of intersection of the terminal side of the angle of the 60 degrees is the 1/2 and root of 3 over 2. So by now, we can first get the cosine of the 60 degrees and the sine of the 60 degrees. So that is, we put here, cosine of 60 degrees is equal to the x-coordinate of the point of intersection, which is 1/2. And then sine of 60 degrees is equal to the y-coordinate of the point of intersection, which is the root of 3 over 2. Okay. Now let's look at another case. And this time we begin with the angle of 30 degrees. And in a similar way, we can form such a triangle in which we have the 30 degrees, 60 degrees, and 90 degrees. So as in the previous example, we know the length of this neck is just equal to the half length of this hypotenuse. So the length of the hypotenuse is equal to 1. So this guy is equal to 1/2. So that means this time the y-coordinate of the point of intersection is equal to 1/2. So we mark this out. We have this length of this neck is equal to 1/2, so that the y-coordinate of the point of intersection for this 30 degree is equal to 1/2. Then this just implies you have the sine of 30 degrees is equal to 1/2, right? And in a similar way, you can find the y-coordinate of the point of intersection, which is equal to √3/2. So that means cosine of 30 degrees is equal to √3/2. So actually, we may also find the other multiple of the 30 degrees. So let me draw some lines. So this is 30 degrees, and this guy is also 30 degrees. And let me extend this ray in this direction. So this is also 30 degrees. By the symmetry, we know for this point, its y-coordinate should be also equal to 1/2, right? So you have the 1/2 as the y-coordinate. And what is the x-coordinate of this point? By the symmetry, negative √3/2, right? Because the x-coordinate of this point is √3/2, so the x-coordinate of this point should be negative √3/2. Then for this one, it should have the same x-coordinate at this point. So for this point, its x-coordinate is the negative √3/2, and then negative 1/2 for the y-coordinate, right? Then for this one, we have the same x-coordinate at this point, so that is the √3/2, and then we have the negative negative y-coordinate, so that is the negative 1/2. So now we can find the cosine and the sine values of some other multiple of 30 degrees. So we know this guy here, what is the degree measure of this angle? 150, right? You see this is the 30 degrees. So you have the 180 degrees minus 30 degrees, you get the 150 degrees, right? So that means you have the cosine of 150 degrees equal to negative √3/2, right? And then you have the sine of 150 degrees equal to 1/2, right? Now, what is the degree measure of this angle marked by this blue arrow? 210, right? Actually, it's the 180 degrees plus 30 degrees, so it's the 210 degrees. Now from here, we know we have the cosine of 210 degrees equal to negative √3/2, right? And then sine of 210 degrees equal to -1/2, right?